Ceres has one prominent mountain, Ahuna Mons. This appears to be a cryovolcano and has few craters, suggesting a maximum age of 240 million years. Its relatively high gravitational field suggests it is dense, and thus composed more of rock than ice, and that its placement is likely due to diapyrism of a slurry of brine and silicate particles from the top of the mantle. It is roughly antipodal to Kirwan Basin. Seismic energy from the Kirwan-forming impact may have focused on the opposite side of Ceres, fracturing the outer layers of the crust and triggering the movement of high-viscosity cryomagma, muddy water ice softened by its content of salts, onto the surface. Kirwan 2 shows evidence of the effects of liquid water due to impact melting of subsurface ice. A 2018 computer simulation suggests that cryovolcanoes on Ceres, once formed, recede due to viscous relaxation over several hundred million years. The team identified 22 features as strong candidates for relaxed cryovolcanoes on Ceres' surface. Ahuna Mons, an ancient, impact-cratered peak, resembles Ahuna Mons despite being much older, due to it lying in Ceres' northern polar region, where lower temperatures prevent viscous relaxation of the crust. Models suggest that, over the past billion years, one cryovolcano has formed on Ceres on average every 50 million years. The eruptions are not uniformly distributed over Ceres, but may be linked to ancient impact basins. The model suggests that, contrary to findings at Ahuna Mons, Cererian cryovolcanoes must be composed of far less dense material than average for Ceres' crust, or the observed viscous relaxation could not occur. An unexpectedly large number of Cererian craters have central pits, perhaps due to cryovolcanic processes. Others have central peaks. Hundreds of bright spots, faculae, have been observed by dawn. The brightest in the middle of 80 kilometers, 50 miles. Acater crater. The bright spot in the center of Acater is named Cerealia Facula, and the group of bright spots to its east, Venalia Faculae. Acater possesses a pit 9 to 10 kilometers wide, partially filled by a central dome. The dome postdates the faculae and is likely due to freezing of a subterranean reservoir, comparable to Pingos in Earth's Arctic region. A haze periodically appears above Cerealia, supporting the hypothesis that some sort of outgassing or sublimating ice formed the bright spots. In March 2016, dawn found definitive evidence of water ice on the surface of Ceres at Oxo crater. On 9 December 2015, NASA scientists reported that the bright spots on Ceres may be due to a type of salt from evaporated brine containing magnesium sulfate hexahydrate, magnesium sulfate 6H2O. The spots were also found to be associated with ammonia-rich clays. Near-infrared spectra of these bright areas were reported in 2017 to be consistent with a large amount of sodium carbonate, Na2CO3, and smaller amounts of ammonium chloride, or ammonium bicarbonate, NH4HCO3. These materials have been suggested to originate from the crystallization of brines that reached the surface. In August 2020, NASA confirmed that Ceres was a water-rich body with a deep reservoir of brine that percolated to the surface in hundreds of locations, causing bright spots, including those in Acater crater.